This is the AP Chemistry review for topic 1.1, moles and molar mass. Our first example is asking us to calculate the number of atoms in a 92.8 milligram sample of silicon, and we're given that the molar mass of silicon is 28.09 grams per mole. We're also asked to use scientific notation and significant figures in our response. So when we're dealing with questions involving grams, moles of atoms, the best approach would be to use dimensional analysis. So in this case, we're going to start off with the dimensional analysis with our given, which is 92.8 milligrams of silicon. And we're going to convert this to grams. And we know that 1,000 milligrams is 1 gram, so we can set our conversion factor to be 1,000 on the bottom and 1 grams. And now that our milligrams would cancel. And then from 1 grams, we could do our molar mass, so 28.09 grams of silicon over 1 mole of silicon. And then we can use Avogadro's number, which relates to from moles to atoms. So we can say 1 mole of silicon is 6.022 times 10 to the 23rd atoms of Si, silicon. And now we see that our milligrams cancel, grams cancel, moles cancel, and now we're left with atoms. So once you do this operation on your calculator, you should get 1.99 times 10 to the 21st atoms silicon. Our second example asks us to calculate the mass in grams of a sample containing 7.35 times 10 to the 23rd bismuth atoms. And we're given that the molar mass of bismuth is 208.98 grams per mole. We're also asked to use scientific notation and significant figures. So let's start off with our given. So we're given 7.35 times 10 to the 23rd Bi atoms. And then we're going to convert this to moles using Avogadro's number. So 6.022 times 10 to the 23rd atoms of Bi and 1 mole of Bi. And then we're going to convert this by using another conversion factor and using our molar mass to convert this to the grams. So we have 1 mole of Bi, and that is 208.98 grams of Bi. So now that our atoms of Bi cancel out and then moles cancel out, we're left with grams of Bi. Once you do this operation on your calculator, you should get 255 grams of Bi, which is 2.55 times 10 to the 2nd grams of Bi. Our third example asks us to calculate the moles in a 7.89 kilograms sample of aspirin. The molar mass of aspirin is 181.18 grams per mole. Use scientific notation and significant figures. Once again, we're going to start with our dimensional analysis using our given, so 7.89 kilograms of aspirin C9H8O4. We're going to convert this to grams first because we need to convert this to moles eventually, and 1,000 grams is 1 kilogram. So we're going to say 1 kilogram and 1,000 grams, and then 181.18 grams of C9H8O4 is 1 mole of C9H8O4. And we see that our kilograms cancel out and then our grams cancel out. And now that we're left with moles of aspirin. Once you do this operation on your calculator, you should get 43.5 moles or 4.35 times 10 to the first mole of C9H8O4. In the next video, we're going to be talking about topic 1.2, mass spectroscopy of elements.